So let this serve as a addendum / correction to virtual lecture number 10. And so around the 15-minute mark, we're developing this concept of high spin versus low spin. And the two complexes that I selected for this example were these of manganese and both of those are +2. So both of those are D5. And I went through the whole argument. I said that the water one was the low spin option. So they would have these smaller, splitting power, larger delta O. Whereas this one smaller delta O. Then, if you go to the end of the lecture, we did the same type of thing with iron, where we had bromides and phosphines, and it was the reverse. That's because later on I did it right, and here I did it wrong. Should I pause so I can swear? No, we won't worry about that. And so, on your homework question, it'll be graded correctly no matter how you answer it, that particular one, as long as you provide an answer. But I wanted to correct this because I don't want you to go forward to another class and then look back at this and say, hey, something's wrong here. All right, so the iron bromine and the iron phosphine that's done at the end of that lecture is correct. This is wrong. So why is that the case? Because I did them backwards. The real reason was I was in my office recording these things for this class and my other class for about 6 hours. And that's just not a good idea, apparently. So let's do it right. So forget that middle part starting at about minute 15 to whenever it finishes. Here's how you do this. Again, the spectrochemical series that we've developed is correct. Halogens enforce a small delta O, whereas these guys over here enforce a large delta O. Now I do this line right here as the transition effectively between when we have one spin state versus the other, and what I got backwards in there we're going to correct now. So this is the same spectrochemical series that's in the lecture. Virtual lecture 11, where we talk about the colors and all that kind of stuff, that's all actually correct. I proofread that, if you will, or looked at it over to make sure that I had not made any errors with that. But this particular part is actually wrong. So let's look at what happens. Actually, we can make it pictorially accurate too. All right, we have 5d electrons in both of these cases. They're both manganese too. So the metal oxidation state doesn't change. That's actually important too. That's actually something we have not talked about. So you can worry about that in another course as well. But you can't do this comparison if you change the ligands and the oxidation state of the metals. We've got to keep that the same, which is what we've been doing. So we have 5d electrons we have an oxygen donor. Comparing the two, the cyanide, being at the right-hand side of this petrochemical series, is got the larger of the two. Cyanide complexes, as we said, are always low spin, as are carbonyls, as are phosphines. So the low spin configuration is this one. This is the reverse of what I had up here last time, but this is correct. The high spin situation, you'd observe for oxygen donor, or if it was a nitrogen donor, if it was a halogen, you get the high spin. So this is correct. What's in the middle of that lecture is wrong. So I apologize for that, and I hope it doesn't cause a whole lot of confusion. But again, your homeworks will be okay. I just want you to make sure you know how to do this for future classes. So again, my apologies for that. But hopefully now we stand corrected.